Hello, everyone. We are going to get started with our very first section here in Chapter 9, which really should be pretty much our last chapter that we do this year. We may do a couple more things after Memorial Day, but those will just be kind of 1 or 2 day lessons. This is our last full chapter. If you want to go ahead, we're on page 278 here in our student journal. Chapter 9 is going to be a lot like Chapter 8, where we're really shortening things down quite a bit because we're really just trying to get through the most important things before you move on to next year. So it's going to be just about as quick. We're going to spend about 2 weeks, maybe a little bit more than 2 weeks on Chapter 9. So we're cutting a couple things out. That's really why I only have just the one vocab word here. All right, so a radical expression, an expression that contains a radical. All right, because Chapter 9, it's similar to Chapter 8. Chapter 8 was mostly about graphing those different quadratic equations. Chapter 9 is going to focus more on just the solving, which we've done a little bit with the factoring problems that we've done. We're going to get way more into different types of solving. But before we can really do that, we've got to get into what we call radical expression, which if we want to simplify that a little bit, we can call those basically what you want to think of as square roots. Okay, so a radical expression is anything that looks like this. It can have just a random number in it. If it has square root of 9, we know we can simplify that to 3. We know that radical expressions too, we're not going to deal too much with these, but just so that you see them, you can also have more than just square roots. So basically a square root is anything where if I multiply it, something by itself, I get 9. So in other words, the square root of 9 is 3. But if I write it something like this, where I have a little 3 in there, that basically means something that I have to multiply 3 times to get that number. So 2 times 2 is 4 times another 2 would be 8. So the cube root of 8 would be 2. We're not dealing too much with cube roots this year. Just wanted you to have seen at least one. All the problems that we're going to do today, all the radical expressions that we see are going to be square roots, but anything with that basic symbol at all, those are all radicals. All right, so we're going to be what we call simplifying these radical expressions today. That's what we're focusing on. When I say simplifying, that means you have to do a little bit more work than just typing something into your calculator. There's a way that we can simplify these. Look at the example it gives you right here. Okay, we can have, it says 9 times 5, so the original problem it would have given us would have been something like the square root of 45. Now you can easily type that in. If you have a calculator, you can go, okay, the square root of 45, and you get 6.7, you get this long decimal. But when we're simplifying radicals, we don't want the decimal. We want to simplify this in another way. So one of the ways that we can do this is with the product property. That's the main way we're going to do this. Okay, the product property says the square root of 45, well, we know that's the same thing as the square root of 9 times 5. And I know that's the same thing as the square root of 9 times the square root of 5. That's really what the product property is saying. It's that step right there where we're saying, okay, well, if I have a number, I can break into 2 factors. Right here, I broke it into 9 and 5. Well, then I can separate it out. I can say, well, then that's the same thing as the square root of 9 times the square root of 5, which I can simplify a little bit more. I know the square root of 9 is 3. So I've got 3 square root 5 there. That is simplified. When you don't have any square root factors there under your square root sign, that means you have it simplified, okay? So again, I don't want 6.7, whatever you get when you type that into your calculator. I want to have a number on the outside if you have a square root that you can take out. And then again, no square root factors. in your square root sign. Okay, so we're going to have a couple different examples. I don't love all the examples it has in the student journal. We do a couple different types of problems than the student journal does, and then the student journal does a bunch of really complicated things. So I'm just going to give us a bunch of examples here. All right, so I'm going to start here. I may have to hop over to another blank page if I end up running out of room here. So let's look at a couple different examples. I'm going to do square root of 18, square root of 80, and the square root of 54. Okay, one of the main things to keep in mind with these, at your homework today at the top I have a list of perfect squares. You want to be thinking this whole time, and it may actually help to have your factor sheet with this as well. You are trying to think, okay, can I divide out a perfect square? So perfect squares, you have 1. That doesn't really help us ever, right? Dividing by 1 isn't going to change us, change the number. 4, 9, I got 16, 25, 36, 49, 64, 81, and 100. Those are probably going to be the most useful ones for us. Okay, so looking at 18, you want to be thinking, okay, what perfect square factor do I have in 18? And I can think, oh, I have 9. Okay, I've got 9 and 2. And the way this works is you're thinking, okay, I can take the square root of 9. I know that the square root of 9 is 3. Okay, the 2 has to stay in the square root because I can't find an even square root for 2. Okay, I'm going to start skipping this step. We can separate out the 2 factors, and then when you can find the square root of something, it will come out of that square root sign. Okay, so when you go from the square root of 9, when you find that square root and it's 3, that comes out of your square root there. Okay, I'm just going to give us some more examples. So 80, we're thinking, okay, what are some square root factors of 80? If you look at your little factor sheet, you're going to see 16 and 5. So 16 and 5. 80 is the same thing as 16 times 5. I know that when I find that square root of 16, that is just going to be 4. I found the square root, so it comes out of the square root sign. I have 4 times the square root of 5. Okay, when that number is there outside your square root sign, it's being multiplied. So that's saying 4 times the square root of 5. You don't only need that multiplication sign for it to be simplified, though. Your final answer looks like that. Okay, 54. I have 9 times 6. Okay, so the square root of 9 is going to be 3. That 3 is going to come out of the square root sign, out of the radical. The 6 is just going to stay inside, right? You don't have any square root factors of 6, so there's nothing to simplify. You're just going to leave it just like that. All right, I came over here where I had just a little bit more room. You can still put this somewhere in your student journal, or if you have another piece of notebook paper, anywhere you like to keep your notes is fine. I've got a couple more examples, so let's do, I've got 108, 56, and 5, 27. So I already have a number outside that one. So 108. If I'm thinking about my perfect squares, I know, okay, well, that's 9 times 12. Okay, I'm kind of making a mistake on this one on purpose. Okay, 9 times 12, so I know that's 9 times 12. I know the square root of 9 is just going to be 3. That's going to come out, so 3 square root of 12. Right, that feels like we should be done, right? We took the square root of one of the factors, but if we really think about this for a second, we're not quite done because 12 has a square root factor. Okay, 12 can be broken down even further into 4 times 3. Okay, so I can find the square root here of 4, which is 2. Okay, the 2 is going to come outside. The 3 is going to stay inside. Right? And any numbers you have on the outside of those radicals, those get multiplied together. So for your final answer, 3 times 2, you get 6, and you leave that 3 right there. I kind of just wanted to show you how to fix a mistake, because the simpler way to do this problem is to look at that and see, oh, that's 36 times 3. But we're not always going to see the easiest factor. We're not always going to see the biggest factor right away. Okay, if I simplified that, square root of 36 is 6, and then square root of 3. We get the same answer no matter what we do, but sometimes we're going to take out a factor, we're going to take out a 4, we're going to take out a 9, and then realize, oh, there's another perfect square factor that I didn't see at first. Okay, as long as you just keep taking out those squares and then multiplying these numbers like I did here, you're still going to come up with the right answer at the end. The way you know you're done, the way I knew I wasn't done here, 12 has a perfect square factor. 3 doesn't have any perfect square factors. So you know you're done when none of the factors of that number are a perfect square. All right, let's look at 56. Again, if I'm thinking of those perfect squares, I can see if I look at my factor sheet, check in my calculator, whatever I can do, I know 56 is the same as 4 times 14. Okay, the square root of 4 is going to be 2. That's going to come out of my square root. And 14 is not a perfect square, and it doesn't have any perfect squares as part of it as a factor. So I know that that's just going to be my final answer. Okay, I can't divide that by 4 or anything else. All right, 5 square root of 27. Okay, 5 square root of 27. I'm thinking, how am I going to break down that 27? I can think, okay, well, 9 is one of my factors here, and 9's a perfect square. So 9 times 3. And again, when that 9 comes out of my square root sign, it's going to be a 3. Okay, so I'm multiplying not 5 by 9, but 5 times 3, and I leave the other 3 on the inside of my square root. Okay, 5 times 3 is 15. I get 15 square root of 3. All right, I'm going to do a couple where I already have maybe some numbers on the outside where I'm multiplying 2 different things together. All right, so now we have some multiplication problems. I would say that probably the most mistakes that I see on this section are here with these different types of multiplication problems. The main thing to keep in mind, and we can even make a note to ourselves over here, you want to multiply the outsides, okay, what we might call our coefficients, and then multiply the insides, whatever is in our square roots. All right, so here on number 4, I can multiply what I have on the inside of each of my square root signs. The square root of 8 times the square root of 2 is just the same thing as the square root of 8 times 2. Okay, 8 times 2 is 16, so the square root of 16 is just 4. My final answer here doesn't even have a square root at all. It's just 4. So that's one way to do it. Another way to think about this is you want to simplify everything you can and then multiply. So another way to do the same problem would be, okay, 8 I can simplify. I know that 8 is 4 times 2. I'm not going to forget about my square root of 2 here. Okay, the square root of 4 is going to be 2. Okay, times the square root of 2 times the square root of 2. So when I have something that looks like this, again, I want to multiply everything that's inside a square root sign. So I don't have anything outside of here. I could think of it like a 1. So 2 times 1 is still just 2. And inside my square root sign, I have 2 times 2. All right, so I have 2 times the square root of 4. And I know the square root of 4 is just 2. So I have 2 times that square root of 2, which is also just 4. That's what I got over here. Okay, so there's multiple ways to attack the same problem. I think that this way is easier on this problem. It kind of just depends on the numbers that you're given. Sometimes it makes sense to multiply everything together and then just simplify all at once. Sometimes it makes more sense to simplify each one and then multiply them together. It kind of just depends on the problem, but either way we get the same answer. All right, so let's look over here at 5. I could do this one where I multiply the outsides and multiply the insides, right? Where my outside, I really just have 3 times 1, so I have 3. And my inside, I have 8 times 36, which gets me 288. I don't know, but I could look at my factor sheet and see, okay, 288 divided by 8 is 36. Well, I just did that, so I should know that. So 36 times 8. 36 is my perfect square. That's why I want to take that number out. Okay, the square root of 36 is 6, so 3 times 6. Square root of 8. 3 times 6 is 18. Square root of 8. But I think the easier way to solve this problem, and we might have seen this as I was explaining, it's easier just to simplify first and say, oh, well, the square root of 36 is just 6. Okay, so when I have this, now I can consider the 6 something that's quote-unquote on the outside of my square root. Since it isn't under a square root sign, it's something I can multiply with the 3. 3 times 6, I get 18 square root of 8. Okay, so the point I was just trying to make here is sometimes, like on this first problem, it's easier to multiply everything together and then simplify. Sometimes it's going to be easier to simplify the things that are obvious and then multiply together afterwards. Again, it doesn't really matter because you get the same answer either way. Even if you kind of have a roundabout way of getting to the answer, it's still going to be right. Alrighty, so I noticed a problem as I was editing. If you're smarter than me, you've already caught this. When I saw that 18 square root of 8, I should have known that I wasn't done. I didn't double check and see my 8 that I have right here has another square root factor. Alright, so really I should have said that since I can break 8 into 4 and 2, I'm not quite done. All right, 4, square root of 4 ends up being 2, so 18 times 2, and then I have this square root of 2, and then I can multiply those, so 18 times 2, I get 36, so it's 36 square root of 2. All right, just like I showed you a little earlier, you're not always going to find the biggest factor. I should have seen that 288, that's 144 times 2. So I could have pulled out a 12. Square root of 144 is 12. But again, that's the nice thing about these problems. If you notice a mistake, if you notice a way you could have done these a little better, you don't have to erase everything and start over. You can say, oh, I can take one more factor out. Let's finish this up. So over here as well, this 18 square root of 8, I should have, again, both of these should have been simplified a little bit more. Okay, so really I should have simplified here this 3 square root of 8. I should have made that 3 times 4 times 2. 3 times the square root of 4 times 2. Okay, then 3 times 2 square root of 2. This should have been 6 square root of 2. All right, so if I want to look at it this way where I should have simplified everything first, I really should have ended up with 6 square root of 2 times 6, and then 6 times 6 I get 36 square root of 2. All right? I know this is obviously one of the easier mistakes to make, so once you simplify once, go back and double check. Is there something else that I can do to simplify this? Because it's very easy, especially on these multiplication problems, to miss something there to simplify. All right, we're going to go back and then we can finish number 6. All right, I've got one last example, and then we can be done. All right, so let's multiply everything together first, because there's really nothing to simplify. If I tried to simplify each one of these, okay, square root of 3 isn't anything. And the square root of 6, I don't have any perfect square factors. I don't really have anything to simplify by first here. So on this one, I'm definitely going to multiply. Okay, I'm going to multiply my outsides. I'm going to multiply 6 times 2. And I'm multiplying my insides. I'm multiplying 3 times 6. Okay, 6 times 2, I get 12. And 3 times 6, I get 18. And I can go ahead a little further and I can simplify square root of 18. All right, I have a perfect square factor. I know that's 9 times 2. And I can take that square root of 9. I have 12 still on the outside. Square root of 9 comes out to 3. Right, still the square root of 2 at the end. And then 12 times 3, I get 36. Square root of 2. Right, I have an assignment. It's just a worksheet. It's not something out of the book. I didn't really love the book problems on this one. And we're going to get started ahead on 9.2 tomorrow. And I'll see you guys soon.